Hi, my name is NicoleBrayiannis, and I will be summarizing research which looks at how American Sign Language impacts the audiovisual speech perception of a spoken language. So to begin, let's investigate the motivation. The researchers sought to discover the ways in which learning American Sign Language affects the audiovisual phoneme comprehension of a spoken language. More so in specific, they investigated how neuroplastic changes to the native language in the brain is due to acquisition of a second language. The two main brain regions they focused on is the superior temporal sulcus, which is involved in biological motion processing, bass perception, and most movements that mirror speech in its auditory spatiotemporal dynamics. And the second brain region is the supramarginal gyrus, which is involved and active during lip reading and involved in phonemic processing. The researchers wanted to compare the differences in linguistic multimodal information processing by looking at how English, which uses audiovisual cues, and ASL, which uses spatial and corporal cues, will often communicate using both spoken and sign language simultaneously in hearing signers. This is known as code blending, and when sign language learners are first beginning the new language acquisition, they often borrow mouthing in order to comprehend newly acquired lexical items and thus rely on their visual system to process language, which the authors speculate may impact audiovisual processing in the spoken language. So the hypothesis is exposure to a novel sign language will change monolingual audiovisual processing. For methods, participants, there were 17 right-handed hearing L2 learners of ASL. That means that they were primary English speakers and were learning American Sign Language, and 17 hearing English controls. The researchers used a 2-time point longitudinal study. So ASL learners were actually recorded first at the start and then approximately 13 weeks later, whereas non-signers were recorded first at the start and then approximately 4 weeks later. They were tested on their ability to categorize words in an fMRI scanner that was for ASL learners. And what they would have them do is they had them view English speakers saying various English words. They were then asked to identify if words started with a sound produced on the lips or not. For example, on the lips would be words that begin with M, B, or P, whereas words not visible on the lips would be K, G, or S. And they were asked to press buttons about whether or not they started on the lips. All words were limited to 4 phonemes in length. So controls tested behaviorally on the same task outside of a scanner to ensure that the results were not due merely to practice effects of being within an fMRI scanner, and also that looked at different ways in which noise affected the outcomes. To analyze the results, researchers used a multiple regression analysis, which consisted of an ANOVA that used within subject factors that looked at time 1 versus time 2, and between subject factors that looked at American Sign Language learners versus controls. They used a probability of 0.05 in order to investigate significant results. Results indicate that ASL learners were better able to determine the location of a speech sound in their English language after only 13 weeks of learning, so 1 semester of ASL. So they showed about an 11% increase in task performance, as well as no difference in reaction times within groups from time 1 to time 2. Furthermore, ASL learners' rating of co-sign speech, which is mouthing and lip reading during sign language, so the use of this and lip reading ability was correlated with SMG activation, but surprisingly not with STS. So between time 1 and time 2, ASL learners showed greater activation of SMG bilaterally when categorizing phenomena in an audiovisual task. That can be seen here in this chart. So from time 1 to time 2, SMG activation increased. So implications of the research, because only SMG activation was recorded and not STS, therefore sign language offers a unique opportunity to focus on the phonological form presented on the lips and not the integration of auditory and visual information. Furthermore, it contributes to the understanding of multimodal processing and experience-induced neuroplasticity. Because new learners of sign language often look at the mouth of sign language teacher, this prolonged eye gaze at a signer's mouth despite actual vocalization is thought to arise due to the learner's attempt to capture English mouthing. The task familiarity was not present with this because activity actually increased in the SMG rather than it should have decreased if there was familiarity with tasks. And finally, for limitations, the authors are unsure if increased lip reading is unique to learning of sign language or if learning a different spoken language would yield the same results. So they offer that future studies should include other bilinguals to compare this brain region activity. And finally, a small sample size leads to low generalizability. Therefore, these results are rather limited to the sample at hand. So this concludes my presentation. Thank you for listening.